Hi, good morning, students. Today we are trying to start the chemical kinetics chapters, right? So, what we need to study about the chemical kinetics? Let us try to understand. Chemical kinetic help us to understand how chemical reaction occurs. This is the theme of the chapter. That is how fast how the reaction taking place. What is the speed of reaction will be there. Okay, whether it will be fast reaction, moderate reaction, or the very slow reaction, and how we will determine the rate of reaction. What will be the factor is going to affect like the temperature, pressure, or the concentration or the catalyst. This all the things we are going to study in this chapter. Okay, after studying this unit you will be able to define the average and instantaneous rate of reaction, express the rate of reaction in terms of change in concentration either of the reactant or the product with time, and distinguish between elementary and complex reaction, differentiate between the molecularity and order of reaction, define the rate constant, discuss the dependence of the rate of reactions on the concentration, temperature, and catalyst, derive the integrated rate equation for the zero and first order reaction, determine the rate constant for the zero and first order reaction, and describe the collision series. So these many points are there which we will be able to learn in this chapter. Okay, now let's try to understand this point, student. Chemistry by its nature is concerned with the change. The chemistry itself is the study of the change in the nature. Okay, substances with well defined properties are converted by chemical reactions into other substances with the different properties. For any chemical reaction, chemists try to find out. The first point which we are studying is the feasibility of the chemical reaction, which can be predicted by the thermodynamics, So the very first things you are going to understand, that is feasibility of the chemical reaction, right? Now, how can you be able to understand the feasibility? As you know that the reaction with gives free energy is negative at constant temperature and pressure is feasible. So, if the delta G is negative, the reaction is going to take place. Now, the second point, extent to which a reaction will proceed can be determined from the chemical equilibrium, right? This is what the second point. What their extent to which a reaction will proceed can be determined from the chemical equilibrium. So how much the chemical reaction is going to takes place, up to what extent it is going to reactant is going to convert into product, this will be done by the equilibrium, chemical equilibrium. And now the third point you see, student, is speed of chemical reaction, that is time taken by the reaction to reach at equilibrium. Okay, so these all the things we have to understand here. Now, along with the feasibility and extent, it is equally important to know the rate and the factor controlling the rate of the chemical reaction for its complete understanding. So it's not only about the whether it is taking place or not, how extent it is, also we need to understand, that is what are the factors going to control the rate of reaction. For example, okay, which parameter determine as to how rapidly food gets spoiled. How to design a rapidly setting material for the dental filling. So these things, how fast the food is going to spoil, how the dental filling, how it is going to set, or what controls the rate at which the fuel burn in the auto engine. All these questions can be answered by the branch of chemistry which deals with the study of reaction rates and their mechanism, called the chemical kinetics. The word kinetics is derived from the Greek word kinesis, meaning movement. Thermodynamics tells only about the feasibility of reaction, whereas chemical kinetics tells about the rate of reaction. For example, thermodynamics data indicate that diamonds shall convert to graphite, but in rapid reality, the conversion rate is so slow that the change is not perceptible, at all. Therefore, the most people think that the diamond is forever. Kinetic study not only help us to determine the speed or the rate of chemical reaction, but also describe the condition by which the reaction rate can be altered. The factors such as concentration, temperature, pressure, and catalyst affect the rate of reaction. At the microscopic level, we are interested in amounts reacted or the formed, and the rate of their consumptions or the formation. At the molecular level, the reaction mechanism involving the orientation and energy of molecules undergoing collision are discussed. Right. So what the point? Let's try to understand, student, here. In this unit, we shall be dealing with the average. Now, students, see, in this unit, we shall be dealing with the average and instantaneous rate of reaction. Okay. So, see, that is the first one is the average rate of reaction, and the second one is instantaneous rate of reaction, and the factor affecting these. Some elementary ideas about the collision theory of the reaction. So, collision theory of reaction, that is, we have to discuss the elementary ideas are also given. However, in the order to understand all these, let us first learn about the reaction rate. Okay. So, rate of a chemical reaction. The first things which we have to understand, the rate of chemical reaction. Some reactions, such as the ionic reaction, occurs very fast. For example, precipitation of the silver chloride occurs instantaneously by mixing aqueous solution of silver nitrate and sodium chloride. Okay. So, when you talk about the rate of reaction, so they are saying some reactions such as ionic reactions are very fast. For example, precipitation of silver chloride occurs instantaneously by mixing the aqueous silver nitrate and sodium chloride. Okay. On the other hand, some reactions are very slow. For example, rusting of iron, the precipitation of iron and moisture. Also, there are reactions like the inversion of cane sugar and hydrolysis of starch, which proceed with the moderate speed. So, some reactions are proceeding with the moderate speed. They are the moderate speed. Can you think of more example from each categories? Okay. So, let's try to understand the next part. You must be knowing that speed of the automobile is expressed in terms of the change in the position of the distance covered by it in certain period of time. Similarly, the speed of a reaction or the rate of a reaction can be defined as the change in the concentration of the reactant or the product in unit time. Okay. So, rate of reaction here itself is defined, student. The speed of reaction or the rate of reaction. The rate of reaction can be defined as the change in concentration of reactant or product in unit time. To be more specific, it can be expressed in terms of how the rate of decrease in concentration of one of the reactant or the rate of increase in concentration of any one of the product. Consider a hypothetical reaction assuming that the volume of the system remain constant, so reactant is converting into product. So they are saying 1 mole of the reactant R produces 1 mole of product P. If R1, P1 are the concentration of R and P respectively at time T1, and R2 and P2 are their concentration at time T2, then delta T is equal to T2 minus T1. Delta R is equal to R2 minus R1, and delta P is equal to P2 minus P1. The square bracket in the above expression are used to express molar concentration. The square bracket in the above expression are used to express the molar concentration. So, rate of disappearance means rate in decrease, the decrease in concentration of reactant upon time taken. So, that is minus delta R upon delta T. Rate of appearance, so increase in the concentration of delta P time taken, so delta P upon delta T. Since delta R is negative quantity, as the concentration of reactant decreases, it is multiplied with -1 to make the rate of the reaction a positive quantity. The equation 4.1 and 4.2 given the represent the average rate of reaction. So they are also representing the what average rate of reaction. Average rate of reaction depends upon the change in concentration of reactant or product and the time taken for the change to occurs. Okay, so instantaneous and average rate of reaction. So here its concentration of reactant is getting decreased and concentration of product is getting increased. So the slope is telling the rate. Slope is telling the rate. So R average is equal to minus delta R by delta T, that is minus R2 minus R1 upon T2 minus T1. So this is going to be slope. Similarly, this slope is giving in the term of product. So rate is equal to delta P upon delta T. Okay. Unit of rate of reaction. From equation 4.1 and 4.2, it is clear that unit of rate of concentration time inverse concentration time in. For example, if the concentration is in mole per liter and time is in second, then the unit will be mole liter inverse second inverse. However, in gaseous reaction, when the concentration of gases is expressed in term of their partial pressure, then the unit of the rate equation will be atm second inverse. Okay, now try to understand with the example 4.1. For the concentration of C4H9Cl, butyl chloride at a different time given below, calculate the average rate of reaction. C4H9Cl plus H2O, C4H9, this is alcohol plus HCl. During the time interval, time 0, so concentration 0.1, 50 second, so 0.09, 100, 0.08. So this is the concentration of reactant is keep on decreasing. We can determine the difference in concentration over the different interval of the time and thus determine the average rate by dividing delta R upon by delta T. Okay, so let's try to understand the point number 1. So the concentration is 0.1 and here is time. They are talking about 0. Time is 0 and that is concentration at T2 means at 50. How much they have given? 0.0905. 0.0905. So you can see here 0. So concentration T2 minus T1 and time T2 minus T1 with the negative sign. So let's try to put out the value 0.09. This is the negative sum, 0905 minus 0.100 upon how much? 50 minus 0. Now try to solve this one. Firstly, you solve the bracket. If you are solving the bracket, this negative term is going to inside. So minus 0.0905 and plus 0.100. Minus minus plus. So see 0.100 and here is 0905. This is 0. So subtract. So this is going to be 5. 9 minus 0, that is going to be 9, and here is 9 minus 9 going to be 0, and 1 minus that is here nothing is there, so 0. So it is going to be 0.0095. This is the concentration, and now you are going to divide by what? 50. So let us try to divide. 0.0095 divided by 50. So how much it is going to come, student, if you are dividing this one? So point, it is going 00, 000, then 1. So 1 means it is going to 50. So this is 5. 9 minus 5, how much will come? 4. So this one 5 9 ja, so it is 9 will come. So here is what is there, student, 10 power 4 form they are saying na, 0.00019. so if you are writing in the scientific notation, 1.9 into 1234 into 10 ki power minus 4, 1.9 into 10 power minus 4. And if you talk about the unit, mole per liter, this will be mole per liter per second. So 1.9 they have given and 10 power 4 here they have mentioned. So this is how we are supposed to do the rate of reaction, students. Now go for the another case. It can be seen in table 4.1 that the average rate falls from the 1.90 into 10 power minus 4 mole per liter to 0.4 into 10 power minus 4 mole per liter per second here. However, the average rate can be used to predict the rate of reaction at a particular instant, as it would be constant for the time interval for which it is calculated. So to express the rate at a particular moment of a time, we determine the instantaneous rate. It is obtained when we consider the average rate at the smallest time interval, say dt, that is when delta t approaches 0. Hence mathematically, for instantaneously small dt, instantaneous rate is given by r average is equal to minus delta r upon delta t is equal to delta p upon delta t. So as delta t is equal to 0, so r instantaneous minus dr by dt is equal to dp upon dt. So it is going keep on decreasing. Okay, instantaneous rate at t is equal to 600 second. How will we calculate? Let us see here. It can be determined graphical by drawing the tangent at time t on either of the curve of the concentration r and p versus time t and calculating its slope. So in problem 4.1, r instantaneous 600 for the example can be calculated by plotting the concentration of butyl chloride as a function of time. A tangent is drawn so that touches the curve t is equal to 600 second. The slope of these tangents given the instantaneous rate of reaction. So that is, this is the touching here, the slope is touching here. Now the slope of tangent given the instantaneous, so r instantaneous 600 is equal to 0.0165 minus 0.037 upon 800 minus 400. 800 minus 400, so it is 800 and it is 400. And concentration above this also mentioned here, this one concentration are there. So what the answer you are getting? 5.12 into 10 power minus 5. At t 250 this is, at t 350 this is, at t this one. Now consider a reaction Hg plus Cl2, it is HgCl2, where the stoichiometric coefficient of the reactant and products are same. Then the rate of the reaction is given. Rate of reaction means what, student? Minus Hg upon dt equal to minus delta Cl2 upon dt equal to, so that is the here no coefficient is 1. If the rate of disappearance of any of the reactant is same as the rate of appearance of the product, but it is in the following reaction, the 2 mole Hi decompose to the products 1 mole of H2 plus I2. So here the coefficient you can see here 2 is there. So in this case, what you are going to do? For expressing the rate of such a reaction where stoichiometric coefficient of the reactant and product are not equal to 1, rate of disappearance of rate of appearance, the rate of appearance of the product divided by the respective coefficient, since rate of the consumption of HI is twice the rate of formation of H2 plus I2. To make them equal, the term HI is divided by 2. The rate of the reaction is given by, the rate of reaction is what, 1 by 2, minus 1 by 2, HI plus dt equal to H2 by dt equal to I2 by dt. Similarly, for example, here is 5Br minus plus BrO3 plus 6H plus it is going Br2 plus 3H2O. Rate now you can see. So 5 coefficient, so 1 by minus 1 by 5 Br upon dt. Then here BrO3 upon dt equal to 1 by 6 delta H by plus by dt, 1 by 3 Br2 upon dt, 1 by 3 this one. For a gaseous reaction at constant temperature, concentration is directly proportional to partial pressure of the species, and hence rate can be expressed as the rate change in particular in the partial pressure of the reactant and product. For a gaseous reaction at constant temperature, concentration is directly proportional to partial pressure of species, and hence rate can be expressed as rate of change in partial pressure of the reactant and product. This is what the questions. Now student, go for the question number 4.2. The decomposition of N2O5 in CCl4 at 318 Kelvin has been studied by monitoring the concentration of N2O5 in the solution. Initially the concentration of N2O5 is 2.33 mole per liter, and after 184 minutes it's reduced to this much. The reaction takes place according to this equation. So this is the stoichiometric is deficient, so average rate you can calculate this one. So after plugging the value, you will be able to calculate you will get the answer. So next heading we are going to study factor influencing the rate of reaction. So till then, thank you so much for watching, student. Okay.